air-conditioned, appropriately level air-conditioned building on one of the warmer days we've had this year. It's great to see so many faces. If you're at home, hopefully either you have air conditioning or you're somewhere where you don't need air conditioning. Garth reminded me earlier that we are coming from this camera today and not that camera today. So I will hopefully look you right in the eye over the next couple of minutes. For those of us here in Ottawa, is this anybody's first time at an OWASP Ottawa meetup? Awesome. A few new faces. Welcome. This is a very open and welcoming group, and we try and make this a safe space for everyone who wants to participate. We'll have some talks today, and as we go through this conversation, there's certainly no stupid questions, and everybody's welcome to be involved and engaged and participate today. As far as the organization overall goes, OWASP Ottawa, the chapter, again, very open and inclusive. Flipping through here on the screen are a number of slides, including one that you will notice is the wrong one. If you were here last month, you will remember the presentation that we had from Dimitri on Microsoft 365. It's not happening again tonight. Please stick around. We're not going to go through that again, as interesting as it was. We've got a great new talk that I will talk to you about in just a minute. Before we get there, some of the things about the OWASP Ottawa group that you have to know. Here you can, that was really good timing, self-register for an invitation to our Slack group. That's a great community for OWASP Ottawa to connect with other people here in Ottawa or connected to our group. It's got a good jobs page. It's also just a good open chat, including a place where we can connect about projects going on within OWASP. I think that we've got somebody in the group who is connected directly to the ZAP project, I believe. And so if you want to be really closely involved with what's going on at OWASP, that's a great place to get started. We do this event every third Wednesday ish of the month. Am I right on this one? Third Wednesday of the month ish. We are do our best to host this here. There is a quarterly that we try to do just a little bit on the edge of town. More to come on the next one of those as it gets scheduled. But keep an eye on us on the OWASP Ottawa chapter group on Meetup, which is probably where you found this. And we'd love to see you again at the next event. I think that's most of the important PSAs. If I miss something important, somebody will jump in and tell me. That is a great opportunity for me to introduce who is going to give us a really interesting talk this evening. First, who here is familiar with the Oracle problem? Show of hands, anybody know what the Oracle problem is? It's not a problem that you deal with when you're doing blind SQL injection on a specific type of database. It's a different kind of problem. Nazanin Bayati is here tonight to talk to us a little bit about the Oracle problem, how it presents itself when you're doing large-scale automated testing, and some of the challenges that it might present, as well as some research that she's been working on to perhaps get around or alleviate that challenge and make your testing more effective and more scalable. Nazanin is a highly awarded and respected academic working on her PhD here at the University of Ottawa. The talk that she's going to give is going to be, I think, incredibly insightful for anybody who likes to think about testing, automated testing, and how to come through some of the challenges that that kind of approach can take in order to make us a little bit more or a lot more effective in the work that we do. So, without further ado, I'm excited to bring to you Nazanin Bayati. Thank you very much. Let's hear it.
Okay. I'm just doing it. We need to stop sharing from that. So I'm sharing this. Perfect. Hello, everyone. Thanks for joining today, and thanks, Adam, for introducing me. And hello for the people who are joining us at home. So today I'm going to present my project titled as Metamorphic Testing for Web System Security. Let's start by a little bit of background about me. So as Adam mentioned, I'm a PhD candidate in computer engineering in the University of Ottawa under supervision of Professor Lionel Bryant. My research field is on automated security testing, and today's presentation is one of the projects that I completed during my PhD. So we are all familiar with web systems. Web systems are main means of delivering online services like e-commerce and online banking. So these systems manage critical assets like card transaction, and they often store sensitive information like customer data. So it's essential to verify that web systems are secure. As an example of incident that happened back in 2016, I can mention when hackers stole $81 million from Central Bank of Bangladesh. Or even recently, let me hide this from the presentation, you can see. Okay, so even recently, hackers were able to gain access to partial customer data of Shopify. So in security testing, we aim at verifying that the software meets its security properties. For example, consider a university website. A student should not be able to change her grade, right? So software testing, or we can say security testing, consists of providing inputs to the software and verifying that the software outputs are valid based on the system specification. For example, consider the university website, as I mentioned. So as the input, I can have a student like Alice with the password 1234, very safe, and she wants to log into a student's portal. So the valid output is to retrieve and see the student's portal, right? There is a concept of Oracle in security testing, or in general in software testing, that an Oracle is a procedure to determine for a set of given inputs to the software the correctness of the outputs based on the system specification. For example, consider the same university website. When I have Alice as a student and she wants to log into a student's portal, the valid output is to see the student's portal. Or when I have admin who wants to log into admin's portal, the valid output is to see the admin's portal. But when I have Nazanin, who is a student, and she wants to log into admin's portal, she should get an error message. So we can say that an Oracle can consider whether a resource like a URL should be shown to the user or an error message should be displayed. The main point here about the Oracle is that when we have automated testing, we need automated Oracle as well. So here we come with a challenge. It's infeasible to define a procedure that automatically determines the correctness of the output for all given inputs to the system based on the system specifications. So you may have this question, no one works on it? So we can say that existing automated testing tools, they don't address the Oracle problem, or they partially address it, which means that they target security issues that are easy to detect, like when the system crashes. And furthermore, they focus on a particular security issue, like they just focus on injections, or they just focus on buffer overflow. So our goal in this project is to address the Oracle problem in automated security testing for a large number of vulnerabilities. We have one more concept, and then we will get into the approach. So any of you is familiar with metamorphic testing, or have you ever heard of metamorphic testing before? Okay, good. So for those of you that are not familiar, metamorphic testing is based on a very interesting idea that it says, you know, it's better, it may be simpler to reason about the relation of the outputs of multiple test executions, they call it metamorphic relation, instead of, considering the relation between the output for a given input to the system. So there are a couple of definition or phrase in metamorphic testing that I will mention them quickly. So first of all, in metamorphic testing, system properties are considered as metamorphic relations that are used to automatically transform initial set of inputs into follow-up set of inputs. So what does it mean? So we have an initial input, and from the name is the set of initial valid inputs to the system that we have. We have a concept of follow-up inputs or we can call it second inputs, that these follow-up inputs are obtained by applying transformation functions to the initial. So what are these transformation functions? Like removing the last character from our initial inputs. We will see more examples of these transformation functions later. And in the end, we have the concept of metamorphic relation, which is a possible relation between the output of initial and follow-up input. So this relation for any set of inputs, if it's violated, it's considered that the system is faulty. So let's see an example which makes it more clear. Consider the university website. I will stick to this example till the end of the presentation. So consider we want to test if a student can access a student's portal. So as an initial input, I'm going to select a student, a valid student, who can access a student's portal, like Alice. As a follow-up input, I will modify the user to another valid student based on my system specification, like Bob. So now as the initial, that's the pointer, yeah. So as the initial input, I have Alice who wants to log into a student's portal, and as the follow-up, I have Bob who wants to perform the same action. So here, I don't have an oracle to tell me what's the valid output that Alice is gonna see, or what's the valid output that Bob is gonna see while trying to log into a student's portal. But I know if Alice and Bob are two valid students in my system, and they are doing the same action, they should see the same results, right? So I defined the metamorphic relation that the output that Alice is gonna see and the output that Bob is gonna see while logging to a student's portal should be equal. So for any combination of the valid students based on the system specification, if this metamorphic relation is violated, it means the system is faulty. So we propose MST-wi as our approach that uses the idea of metamorphic testing to target and to test the security properties of a web system. Consider we have a list of security issues from the engineer, and we have a web system that we want to test if any of these vulnerabilities is available, or our system is vulnerable to any of these security issues, right? So the first step is to collect the valid inputs for my web system. In our framework, we have an automated data collector that automatically collects all the valid inputs for your web system. Let's see more details about it. So, any of you is familiar with crawljacks or any web system crawlers? Okay. So, actually, our data collector is based on crawljacks. And we use the data model generated by this crawler. So if you're familiar with, that the crawljacks explore the user interface of a web system to crawl the website, and it generates a data model, which is a graph that then notes our system states reached through the user interface, and the edges are the actions that the user should perform to reach to that state, like clicking on a button, submitting a form, requesting a URL, and etc. So the point here is that the system states in crawljacks are based on the contents of the displayed web page. So in our system under test, we have some web pages that they had dynamic contents, which means the content was constantly changing. In order to avoid never-ending crawling process, we extended these crawl jacks in a way that when we see a new state, we compare this one with all the nodes in the previously traced graph, with all the states that we have in the graph. If it's dissimilar enough, which means if the state based on a distance function that we apply, if its dissimilarity is higher than a specific threshold, we will consider it as a new state. Otherwise, it's considered that's already seen. So this threshold is highly configurable. It's based on the system. For example, we considered only 10% of the length of the web page, which works for our system. But if you want to run it on your system, you can, change the threshold based on your system. And this crawling process continues till no more states are encountered or timeout is reached. So when we have, in the end, we have that data model, as I mentioned, is a graph. We traverse it from the root to the node depth first, and we achieve a set of possible sequences of action that a user can perform on our web system. And this would be our inputs to the web system. So now that we have the valid inputs, it's time to reuse or define the metamorphic relations. Why I say reuse? Because already we implemented a big catalog of metamorphic relations that targets all generic vulnerabilities. And so we expect the engineer or tester or developer to reuse all of our metamorphic relations. But in any case, if you want to define your own metamorphic relations, or if you want to target a vulnerability that is not considered, is not targeted by our metamorphic relation, we developed a domain-specific language tool, a DSL, that you can write your own metamorphic relations. And let's see a little bit about our DSL. So, for the, any of you heard about X-Space, expression language? Okay, so we rely on an extension of the X-Space, which is an expression language, to help us write a DSL. And DSL helps us to have a language close to the natural language that we have. So the good thing about X-Space is that X-Space specifications can be translated into Java program, which can be compiled into executable Java bytecode. So we extended the X-Space by introducing new data representation functions, new Boolean operators, and new web utility functions, that all of these are used in metamorphic relations. And we will see examples of these functions in the next slides. And if, as I mentioned, if the engineer wants to add new functionality to our tool, they can easily just define a new Java API and use it as a function call in the metamorphic relations. But we don't expect the, so I wanted to say that we already implemented a catalog of 76 metamorphic relations, which covers a large number of vulnerabilities. We will discuss exact numbers in the evaluation slides. And this catalog minimizes the efforts of the engineer that wants to define any new, metamorphic relations. And if you're interested to know what's the list of weaknesses, what's the resource that we consider to define metamorphic relations, we consider the weaknesses listed in OWASP Top 10. We consider weaknesses listed in CW Top 25 and CWE view for common security architectural tactics. So now I have valid inputs for the web system, and we have the set of metamorphic relations that we want to test on our web system. It's time to execute them. And we already, in our framework, we automated this process of executing metamorphic relations with the inputs. And the outputs are execution results, which are set of log files, that if any of this metamorphic relation with any of these inputs are violated, it's possible that the system is vulnerable to that security issue. So let's see examples about our metamorphic. So I think we are all familiar with bypass authorization. It's very famous vulnerability. So let's consider that the definition of this security issue is an unauthorized user should not be able to access the admin's information. Very simple definition. So as an initial input, I will select a user who can access the admin's portal. And I will set the action to log in to admin's portal. So as initial, I have admin with very strong password 2023 that wants to log into admin's portal. So as a follow-up input, I will modify, these are all based on system specification. So I will modify the user, to another person that should not be able to access the admin's portal, like Billy. So here, I don't have an oracle to tell me what's the output that admin is gonna see or what's the output that Billy is gonna see. But I know if Billy is an unauthorized user in my system, the result that admin is gonna see and the result that Billy is gonna see while trying to log into admin's portal should be different or not equal. As I mentioned before, for any combination of, we can say authorized and unauthorized user, if this metamorphic relation violated, it means that the system is vulnerable to this security issue. There is one more example. It's about insufficient session expiration. So we know that when we log into a web system, a new session credentials is assigned to a user. But when we log out, we expect that session to be expired, which means another user, the same user or a malicious user should not be able to reuse an old session, right? So let's consider the definition of this vulnerability is that a user should not be able to reuse old session IDs for authorization. So as an initial input, I'm looking for a logout action. Here, user 1 with this password is performing the logout. In order to create the follow-up input, I'm looking for another actions that user 1 performed after the login, like action Y, which means to perform action Y, the user should be authorized, right? So when I want to create my follow-up input, I copy all the information about user 1 to user 2, but I just swap the place of the logout and action Y, right? And I expect if the logout is performed before action Y, the session ID that system is going to assign to the user before and after this logout be different. So this is how we write this metamorphic relation. Definitely, there are many ways to implement this vulnerability. This is just one of the simplest ways to bring an example about the metamorphic relations. And let's see a little bit about evaluations. So we tested our work on 2 big open source projects, Jenkins and Joomla. And the results show that our approach requires limited manual effort and it can detect more than 85% of the targeted vulnerabilities. And the good news is that at most false positive that we get is 1%, less than 1%. And the exact value is 0.19% of the executed follow-up inputs lead to a false alarm, which is a very great value because the problem of most of the tools, commercial tools, is that most of them lead to a large number of false positives. And also, our approach can detect 102 different types of vulnerabilities based on the CWE, which covers 45% of the security issues in the CWE database. And also, our approach can automate 39% of the security testing activities reported in OWASP Top 10 that they are not currently targeted by any of the state-of-the-art techniques. So we took this evaluation a bit further and we start comparing them with the commercial static application security testing tool and dynamic application security testing tool, which you may be familiar with SAST and DAST tools. So for the static application security testings or SAS tool, we compared with SonarQube and SA2. So we relied on the research done by Elder in 2022, and because of the licensing issue, we don't know the name of the second commercial tool that we named it SA2 because we don't know the name, but we had the details from the paper. And for the dynamic application security testing tool, we compared our approach with OWASP ZAP and DA2, the same reason. Because of the licensing, we don't know what's the name of this tool. And so here we go. This is the results on CW Common Security Architectural Tactics. So if we use our approach, you can detect 101 out of 223 weaknesses reported in this CW view, which covers 45% of the vulnerabilities. If you use OWASP ZAP, you can address 17, which is 7%. If you use DA2, you can address the same 17 or 7%. SonarQube can detect, or better to say, can address 16 or 7%, and SA2 can address 67, which is 30% of the weaknesses reported in this CW view. So based on the numbers, you can see that, okay, MST-wi is addressing more weaknesses. But the question is that, what if you are running all these 4 tools on your system at the same time? Like you are running 2 DAS and 2 SAS at the same time on your system. You can only address 84 of these vulnerabilities, of these weaknesses. But in case if you use our tool, you can address more of these weaknesses. So as I mentioned here, the set of weaknesses targeted by our tool is larger than all the weaknesses can be targeted by using all 4 of these tools. But let's see how is the situation on CW Top 25. So if we use our tool, you can address 15 of the weaknesses, which is 60%. If you use OWASP ZAP, you can address 6, DA2 6, SonarQube 4, and SA2 14. So based on the numbers, still MST-wi is addressing more of the vulnerabilities. But let's see if you use all 4 on your system. So if you're using all these 4 tools, you can address 15. But if you use our tool, you can address 15. But it's important to mention that the 15 are just numbers. It doesn't mean that they are exact the same vulnerabilities. Just based on the number of the vulnerabilities that you can target with the tools. So here, based on top 25, the number of weaknesses that you can target with our tool is equal to what you can target by all 4 approaches. And interesting part, OWASP top 10. Let's see what's going on here. So if we focus on the vulnerabilities reported in OWASP top 10, our tool can address 67 of these weaknesses, which is 51%. OWASP ZAP 17, DA2 17, SonarQube 13, which is 10%, and SA2 can address 54, which is 42%. And the same analysis, if you're using all 4, you can address 69, which we can say that if you use our tool solely, the number of the weaknesses that you can address is close to the number of weaknesses that you can address using all 4 tools on your system. So, actually, if you want to know what are exact vulnerabilities that we can address, or what are the vulnerabilities that the rest of them are addressing, you can check our paper. We have a very long, discussion about the vulnerabilities with the exact CV IDs or CW IDs is provided. You can check which vulnerability is addressed or not. So maybe you can have this question that, what are the vulnerabilities that we can detect with MST-wi? So there's a very long list here. So I will mention some of them. So if the feature under test is accessible with URL or with a pass, if the testing framework supports modifying parameter value. As I said, we need to create follow-up inputs. And like if it's possible to log in with a predefined list of credentials and a lot more, I'm not going through all of them. I think it's more interesting to mention what are the vulnerabilities we cannot address with our tool. So if the weakness doesn't concern the mobile-based or web-based vulnerabilities, for example, if it's OS-based, we cannot address it. If the weakness can be discovered only by means of program analysis, so our tool is dynamic analysis, so we cannot target those weaknesses or vulnerabilities. If it's not possible to distinguish valid and invalid behavior of the system, and a human needs to define what's the valid and invalid. So, for example, we have a case that is an improper control for exceptional condition on the system. So something being exceptional or not is highly system dependent, or sometimes it's context based. So if in your company, you know these exceptional situations and you can differentiate the correct and incorrect behavior, feel free to add a new metamorphic relations and target the vulnerability that you want. But because we are addressing generic weaknesses, so we currently we didn't target this. And the last one is that if the weakness can be discovered by controlling a third-party component, for example, we need to have a proxy to connect to communication channel. So for now, we didn't implement it. But maybe in the later versions, we will add this feature to our tool. Okay, let's see about the achievements. So MST-wi is the only approach that includes a large number of, includes a language to express metamorphic relations. It targets a wide range of security issues, and it includes a data collection framework to drive input data automatically. It's the only approach that automates the execution of metamorphic relations in web systems, and it's the only one that automatically detects various security issues based on the metamorphic relations. And as a future direction, okay, so we say that MST-wi is very effective, it can address a large number of vulnerabilities, but the point is that it's a bit time consuming to execute all of our metamorphic relations with all of the valid inputs. So in the last couple of months, in our team, we have started working on reducing the execution time of the MST-wi by selecting the most relevant inputs. And our solution is based on AI. We are using clustering and meta-heuristic search algorithms to complete this project. And so if you're interested to read more about our project, it's already it's published in a TSC journal. So you can scan this QR code to read about our tool. Our tool is available online. Feel free to check. And all the results, all the list of vulnerabilities that we detected, all the discussions is available online. And thank you.
Wow, Nazanin, thank you. And so if I'm understanding that correctly, I can scan that QR code right now.
Yes.
I can go to the project and I can give it a shot on anything that's web or mobile based, and I can leverage that tool to see how it performs against some of the other technologies.
Yeah, actually this QR code will redirect you to the paper.
Well, to the paper.
Yeah,
okay.
And there is a link. I
can't just run the paper.
Yeah, no. And yeah, and in the paper there's a link to the replicatory package, which has the link to the tool that you can install. Yeah.
Amazing. Some pretty powerful numbers against other common techniques that we're used to. What can we take from that? Like as security professionals who are trying to improve the use of our time and reduce false positives and focus what we're supposed to be, or focus our efforts where they're best used. What can we take from that research, leveraging a tool like MST-wi?
Yeah, actually, we wanted to just show that applying metamorphic testing for addressing the security issues is very powerful. So actually, I think it works based on the very small number of false positives and how powerful it is to address the vulnerabilities, even though these numbers were only generic vulnerabilities. We didn't focus on the specific ones. So it might be the number would be larger if you also focus on specific ones. So I think if some company are dealing with this problem, or if they are concerned and they are not satisfied with their current tool, it's worth to try our tool on their systems.
Very interesting. We'll open up to the room, and of course from the internet, if you have questions, go ahead, type them into the chat. We've got somebody who's watching and can flag those or relay them back along. They may even pop up on the screen if we've got that going today. Somebody let me know what I missed. Meantime, a question in the room.
I just want to say this looks incredible. I know on a daily basis I work with Burp Suite, and it's gotten to the point now where the ActiveScape utility, I very rarely look at it. So to have something that's available is very interesting. I think it's more of a broad question, but do you see metamorphic testing replacing those functionalities?
So the question is, and I'll just repeat it for the internet, looks very promising. Do we see metamorphic testing might replace the other types of testing that we've seen popular today?
So saying replacing is a very powerful phrase that, I cannot use that, but I say that it can complement the current tools. And actually we got attention from industry after that we published the paper, and they are looking for collaboration with us to use these tools on their web systems because they are dealing with the problem. Yeah. So if in your company you are interested, email me. We would be happy to collaborate.
So to double click on that a little bit, is the message here that one more tool is better? Or what am I trying to say here? Is the message that if you've got other solutions, this is a tool that can get you more coverage and is less noisy, or can add to your coverage and is less noisy? Or is there some suggestion that the trade-offs might be worth it? That I know you said that replace is a strong word, but if you were choosing any one tool today, those numbers suggest that you might want to look at something that is broadly most applicable rather than something that's only going to be a point solution. Is that?
So so I have to answer this question in a way that it depends on the vulnerabilities that you want to target.
Right.
So if the vulnerabilities that you want to target is already covered in our Metamorphication or in our Metamorphic Testing tool, yes, we can cover more and a large number of vulnerabilities. But if you are targeting a different area, because detecting vulnerability is very wide, so we cannot say that, yes, we can detect all of them. If the vulnerabilities are in the same criteria or in the same category, yes, we can detect more vulnerabilities using our tool.
So today there is a class of vulnerabilities that metamorphic testing is really good at covering because it's in the set of library, and if that's the set and target, you'd want to choose. You'd consider leaning in that direction because you're going to get some efficiency.
Yeah.
Interesting. What are the questions? What is on here?
Aaron Batten, I have 3 questions.
Okay, go ahead, one by one.
I can say all 3, and then you can figure out which ones you want to tackle.
Okay.
The first one is about you and your team. The second one is like a curiosity about your product. And I've already forgotten what the third one was.
So I can start by introducing the team. So I'm the PhD student in that team, and my supervisor, Professor Lionel Bryan, is managing the team. I'm actually working with University of Luxembourg, with SNT Center, with Professor Fabrizio Pastore, and also we had the honor to work with Professor Arda Goknil from University of Oslo in Norway. And yeah, this was a big team.
Nice.
And if this answer your questions, Professor?
No. The question that I had, I imagine you'll have to repeat it for the people who are listening online. This is an amazing product. You're open to people approaching you commercially. I understand the nature of capitalism. If you're not innovating, then you're stagnant. If you're not creating something new, then you're just trying to buy out the competition because they will overthrow you, usurp you from your throne. You have an incredible product that's better than others. Are you trying to get bought out? Are you trying to usurp those
or like.
You mean commercialize the tool?
Yeah.
What's the
Yes.
future of the technology?
Yes,
and how do
actually,
you
as
transfer
I mentioned, we are going to have a collaboration with the industry. So they aim for this tool, and because we prove that it's powerful. It's not some research work, you know. Actually, it's a very powerful research, and we aim for commercializing it. And it depends on our collaboration with the companies and companies who wants to, because sometimes when you are working with a company, they want the tool to be work only on their own, system. But yeah, for sure. Actually, that now we are targeting the scalability of our approach, because in the current project that I'm working, as I mentioned, I'm working on reducing the execution time. So it will affect the scalability of our approach. So definitely when it becomes something fast and powerful, it has the definition of something being commercial.
So it sounds like it's a project that has some exciting technology transfer opportunity. The question for you, Aaron, is did you bring your checkbook? Did you bring your checkbook?
I'll write it up right now. I remember the second question. That was an excellent segue into it. You mentioned speed and scaling up and feasibility. As amazing as it is to have a very text-heavy slideshow, I find things can really excel when you can engage the audience. Do you have a live demo? Do you have a recording of this? Or is it something that is so time-intensive and heavy that you could not really show to a live audience?
Actually, I don't have the demo to show, but because the different, for example, for writing the metamorphic relations, if you remember the slide about, so that part, there's nothing to show. So it's okay, I'm writing. It's like showing your coding. But the demo of the whole project, executing it with already having the inputs and already having the metamorphic relations, it's just, you can run it on the system, and it depends on which metamorphic relations, the time would be different. I don't have it right now, and if you want, we can set a meeting later and I can show you the demo, because I already did for other meetings.
So to double click on that a bit, if we scan that QR code and read the paper and then followed the link and got the project,
Yes.
There is a catalog of MRs that exists.
Yes.
Are those universal? Can I just point the solution at my application and go from there? Or is there configuration I need to do to get
No, there are generic weaknesses. They don't need any specific setting. It just depends on your system setting. For example, you just need to, like, for example, have Chrome driver on your system. You just need to have Eclipse, because it's just as a plugin. You know, this kind
so
of
to get sort of at the
configurations.
question that you have is like, is it so hard that we can't show it quickly? It sounds like technically, if we had the time in the setup, we could take it out of the box. We could point it at a testable application, and it's not like there's a week's worth of, that's an exaggeration, but there's not a heavy configuration up front.
Yeah,
you can run the README and then go from there.
Yeah, excluding the collecting the data, because we need to crawl the web system.
Right.
Excluding that running data.
Amazing. I remember with the third question.
Look at this.
You already asked
Three.
it.
You mentioned the checklist and all the neurons fired at
Okay,
once.
go ahead.
I don't know if you can navigate back to the slides, but the slide just before you hit the statistics and everything looked amazing, you mentioned using transformers. And I'm pretty smooth-brained. I took an iron tonight and just folded out all those wrinkles. Can you elaborate? Because I know there's a lot of transformers within the field of machine learning, neural networks, AI, and all those buzzwords. Could you elaborate on like what sort of transformers you guys use?
So the first one is not a transformer, because transformer is common phrase in large language models. So don't get this one confused with that one. So this is a transformation function where we change the initial inputs based on the functions that we define and the system specification. Like when I say modify the user, this is a transformation function. It's not transformers. That's another concept.
Thank you.
Okay,
The
no problem.
smooth wrinkles are popping back.
Okay, great.
Thank you. Anything from the internet at this point? Well, internet, there are still 6 of you here, 5 maybe. If you have questions for Nazanin, Garth has a question too, and you're going to want to get it ahead of his. Over here in the back.
Okay, sure. I think it was on slides like 18, 19, 20. You're talking about the overlap between your approach and the other.
On the SAS and DAS?
Right, yeah.
Okay.
There was one slide where they were like identical in percentages, and you were mentioning that they are just, the accuracy is about it.
This one?
If you did use your approach in addition to whatever the best SA2, are they doing different ones? Like if you wanted to combine them, you had the resource to combine the two, how much more overlap? How much do they overlap? How much more would you get to combine?
It's a really good question. We already addressed this before because we want to see which one would be the best combination with our tool. So as I mentioned, our tool is dynamic analysis. And one of the vulnerabilities that I mentioned, we cannot detect, not vulnerability, the weakness, is when it needs a static analysis. So the best combination, as we saw based on the list of vulnerabilities, is combining our tool with SA2, which covers more than 92% of the vulnerabilities in CW view. So yeah, because we cannot address the static analysis, so merging it and combining it with something that's already addressing that, it increases the power of the tool. Yeah, that's a very good question.
And so for this, do you notice a lot of false positives, or on this tool when you run it? Is there also a trade-off of any sort, or what you get back is what you get, right? Is there any tweaking sort of where this is susceptible to noticing that there might be a problem and it's worth investigating more, or is it just all or nothing?
So if I understand correctly, you're asking about the false positive rate of our tool. So as I mentioned, the false positives are less than 1% in our tool, is 0.19%, which is negligible for the engineer to determine.
Is SA2 the same?
We don't know this. We don't know the name even. Yeah. So we don't have this information. We got the exact number of covered vulnerabilities from the paper, with the research paper done by Elder, which I reference. So we don't have this information with this, but for our tool. But we know that in general, it's a big problem because having lots of false positives, and it wastes a lot of time of the engineer or the testing team to understand which one is true positive, which one is false positive. So be hopeful that because the false positive rate is very small, so be powerful as it is.
Your question was a little bit richer than that.
So that's I'm curious. So that could be about. So then you're like getting. Let's say that SA2 is also low false positive. You get over 90% coverage with a low false positive rate.
We can assume that.
Okay. You have any guess what SA2 is? Even just intuition? Okay.
No.
Okay.
Yeah.
Thank you.
I'd be interested. Output-wise, your question was a little bit richer in that it talked about both like what's the false positive rate and what kind of feedback do you get to further validate or leverage what you've learned from the tool to go back and complete your reporting. Can you comment at all about where the reporting is at this point?
Okay, if I want to,
the strength or weakness?
If I want to check if I understand your question correctly, you say that what was the feedback that I got from that 1% false positives and how I can make them better? Is that the question?
Yeah, whether it's from the 1% or whether it's from like no, that's definitely a vulnerability. Can you sort of share it all about how we consume the reporting and let's just say, yep, you're vulnerable to this weakness, good luck, or sort of how does the data come back or the input come back for us to be actionable?
So the point is that we got the log files from the execution, so whether they are fail or pass. So we are interested in failures. We are not interested in the one that passed. So the one that failed, because we had to report this false positive, so we checked them manually on the system. And we saw that which of them were actually lead to detecting, and targeting a weakness or detecting a vulnerability on the system. And that's how we realized that, less than 1% of false positives. And if you want to know which are those, because 1% is very less, and we were also thinking that how we can improve that. So it depends on the crawling step. So if some features were not crawled before, or sometimes web system doesn't function as usual. Sometimes it's internet disconnection or something.
Noise,
yeah. So, but because it's just 19%, not 19%, 0.19%, less than 1%. So I think it was checking, using it and then other web systems. I hope it answered your question.
Thanks. Garth, did you have a question?
Yeah, so in the examples you had Joomla and another framework.
Jenkins.
I'm curious, seeing a lot of sites are in Java-based with JavaScript framework on the client. How would the system work in that sort of environment? Would it be different?
So the point is that, so the question is that, can we use this on different web systems that are implemented in different languages or different techniques? And the answer is, so if the elements of the web system, elements of the web page, like buttons, forms, and all of these are available, the URL to them are available in the HTML form, we can crawl the web system. Because like any other system level crawlers, these crawljacks mimics the behavior of the user on your system. Like it logins, click on the button, submit a form, request your, whatever user will apply on your user interface, right? So as long as these elements, like the buttons, forms, are accessible through the HTML, we can use this tool. Otherwise, no. Yeah.
The second question I had is that your technology stack is based on X-Base, and I'm wondering what the criteria you had when you were looking for implementation in terms of stacks, as opposed to something like Select.
Yeah. So that's a very good question. So the question is that why we are using X-Base, and what was the criteria that we choose X-Base as our DSL tool, like developing our DSL. So the answer is that because, first of all, X-Base lets us translate our code into Java codes, which can be compiled into executable Java bytecode. And when we rely on X-Base, we inherit from language infrastructure, like compiler, interpreter, linker, and etc. So we don't need to reinvent the wheel. We already have it, we rely on it, and then we just define our own functions that we need for our metamorphic relation. So it is our work to when we rely on this X-Base.
Just wondering if you could talk a little bit more about one of the examples. You added enable weaknesses of recovery. What was the work process like? Did you have to code for each one, or what was it like? If you could give one example.
I didn't understand the question.
So the question, as I'm hearing it, like what's the work process like as you go through trying to complete to create an MR, or
to increase the coverage? So, for example, talk about session invalidation. Now, let's say session invalidation is the code of the did. What work did you have to do to make that work?
Yeah,
what's the work to expand the coverage?
Okay, so I see. So if you want to add a new, or just a simple process of writing a metamorphic relation to target a vulnerability is that, first of all, we had to read that vulnerability several times to fully understand what's the point and how we can target it in a system. Sometimes the way that we target it, in a system, it's not only single way. There are like the session expiration that I said. We have different versions of the same vulnerabilities with our metamorphic relations. Because we were thinking that, say, okay, this reported that this vulnerability was targeted with this scenario. There are different scenarios. So the first step is to fully understand what's this vulnerability and how we can target it on our system. So every time if we saw any vulnerabilities, we try to do it, manually on the system to see, okay, this is how we can, implement it. And then it's time to write down what would be the initial input for us and what we want the malicious user, or we can say the follow-up input, to perform on our system. Because initial input is a valid input and the follow-up is like a malicious user, behave like a malicious user on the system. And so at this point, we said, okay, we need a couple of functions. For example, when we realize that, okay, we want to modify the user, we start implementing that functionality. So for each vulnerability, there are certain functionalities that you need to write down. And when we implemented it, so even for the evaluation part, sometimes the vulnerabilities for the we call it write part, like the first part to define what's the follow-up input, what's the initial input is the same, but the way that we evaluate whether this is a vulnerability, is vulnerability successful or not is different. So even that part requires to kind of have a good knowledge about that vulnerability that you want to target. So actually, it was one of the, I think, good part that I really enjoyed, because I had lots of discussions with other colleagues that I had, and it was sometimes I feel like it opens a new door to find a vulnerability in that system. But yeah, if you want to, for example, if you know a system, if you want to add a new metamorphic relation in that system, the process is the same. So you have to first understand what's the vulnerability and how you can perform it on your system. Then you need to define, okay, what's the correct behavior that the user should perform, and what's the incorrect behavior that the user should perform. The incorrect behavior would be the follow-up input. So those transformation functions are the functions that will create and will change the initial input to the malicious input that you want. And then you need to think about, okay, how I can evaluate it on the system. Is it enough to say the outputs are different, or I need more functions? Because our metamorphic relations are not just, different, equal. No, it's not like that. We have other functions. We have a function that we check if an alert is shown to the user. We check if this, is an error message. We check if that web page is some content that the user have right to access it. So there are many more. And these examples were two simplest examples that I can provide for this presentation. But these are the steps that you need to perform. And if you see the functionality is not implemented, as I mentioned, you can just write a new Java API, it's a Java function, and use it in the metamorphic relation. I hope we answered your question.
Yes, thank you.
Sounds like there's some reading to be done of that paper.
It also sounds like false positives are low because outputs are very well defined. Expected output.
So the comment was it's possible that the false positives are low because the outputs are so well defined.
So it depends. So it's not always about the outputs. It's mostly about the follow-up inputs. For example, it depends how wide you are testing your system. I'm not saying that it's not related to the output. Yes, it is. But another portion of this equation is the wide range of the follow-up inputs that you can test on the system. For example, you have a big system, you have many users. For example, for SQL injection, we have a big database of possible malicious strings that can be injected to the system. So if we had only 10, I would say, okay, it's not possible to see false positive with 10, strings. And we know that. But when I see that we use a big numbers and a large number of the files to target each vulnerability, SQL was one of them. So, and then also we take care of the evaluation parts. So that's also a reason, as you mentioned, that we see a low false positive, because we try to take care of all possibilities that vulnerability can happen on the system.
And my math is not good, so I'm going to ask this question and see if it's the right kind of question.
Okay.
When we look at the SQL injection example, for example, are we saying that we can take the out-of-the-box metamorphic relation and apply that to a system that has a SQL database underlying, and it doesn't matter what the table configuration is, how many columns, how many tables, the false positive rate or the success of that solution is going to scale without additional work to configure the metamorphic relations or any different part of the system.
You don't need to change the metamorphic relation if you're targeting that specific vulnerability.
Yeah.
But if you know there is other strings that you can inject to your system, that part, the configuration part, would be for adding the new strings or considering new follow-up rules.
Right.
You don't need to change the metamorphic relations.
Right. And detect not exploit.
Yeah, as I mentioned, so if you see there is something, or even the implementation of the vulnerabilities, or not the way you want to perform, which would be system specific, that would be the time to write a new one. But I think the one that we implemented, as I mentioned, we have different versionings. So I expect that you don't need to change the metamorphic relations, but you may need to change the configuration.
Somebody was calling in with a question? No, we're good? Okay.
So, as if I understand correctly, based on how it's set up right now, can we expect it to detect 0 day? Probably.
0 day is a
can you
malware.
detect a 0-day vulnerability with MST-wi?
So 0 day happens as a malware, if I'm correctly mentioning it. So as I mentioned, if it's web-based. So for detecting 0 day, if it's a malware, so it's system-based, it's OS-based, you can check. And it's not anomaly detection. The main point is that our approach is not an anomaly detection on the system. And it's addressing the Oracle and vulnerabilities on web systems. So I guess there are better tools. I saw the news on OWASP page on LinkedIn today that they detected a new 0-day attack malware today. Yeah, I think for that there are other tools that can be applied, not the web-based testing ones.
But it sounds like if there is a class of vulnerability that can be detected and it has not yet been detected in a particular solution, there's no reason that you couldn't detect that type of vulnerability.
Yeah, actually, we detected a new vulnerability in Jenkins that was not reported before.
So there you go.
Yeah. Thank you. Any other questions?
Imagine that, more vulnerabilities in Jenkins. Sorry, Jenkins. We have other questions. I see some eager eyes. There's questions that people want to ask. How are we doing for time? Okay. Still nothing from the internet? You're still here. You must have a question at this point. There's one more from the room.
What would the forward mention that you are looking for an
Yes. So that's a good point. So I'm looking for an internship. So thank you for mentioning that. I'm looking for a research internship in the automated security testing field. So from home, from here, if you have any connections, I can connect me to get an internship. I would be happy to connect. And yeah, my email is in the last page. Let me go back to the.
This is a great plug, of
really
course,
important.
for Nazanin to also join, although I'm pretty sure she's already there, the OWASP Ottawa chapter Slack. And there's a good gig guide in the jobs channel on the Ottawa Slack. If anybody's looking for an intern, you might see Nazanin in that group tonight. Any other questions before we wrap up another great event here tonight? You have the chance to ask the last question.
Okay, if you don't remember the question, you can contact me later as well.
It's not the last opportunity for a question. It's just the last opportunity.
You're pressurizing them. You can contact me later if you have any questions. You can pick me on LinkedIn or with my email. I would be happy to answer your questions. If in your companies you have internship, ping me. If you want to have collaborations, we are open to do collaboration with industry. And thank you so much for joining today. Thanks.
Thank you, Nazanin. I really didn't do Nazanin enough justice. If you've read her bio in the meetup invite, she is incredibly well respected in her field, has done some great work to arrive at a number of awards for the work that she's done, and it's pretty clear that she's been a valuable contributor to this project. Also a valuable contributor to our organization this evening and our knowledge. Again, one round of applause for Nazanin. Thank you.
Thank you.
So that wraps things up for this evening. If you have any garbage, there's a garbage can at the back of the room. We welcome you to pick it up and bring it with you. Help make the room clean up a little bit easier. We really appreciate you guys coming out this week. We haven't announced the next event yet, but I knew there are some good ones in the queue. Keep an eye on the meetup page for OWASP Ottawa. We'll let you know there. Of course, join the Slack. It's good to let us know when a new event's coming up there as well. Meantime, enjoy the summer. Stay cool or warm or whatever you prefer. And we'll see you again here very soon. Take care.